Yes, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at the last bit of our steps used in constructing a frequency distribution. And in this particular case, I've given a tabular form of specific data which we had done from our first video. Now, there were a range of steps which were used in trying to, of course, come up with this specific table. And of course, we had listed a few of the specific terms which we were to come across in, of course, this concept of a group frequency distribution. Now, in this case, I had mentioned about the concept of a range, which was basically the difference between the largest and the smallest value in a specific distribution of data. Now, this one assisted us in trying to find a specific other set of course, numbers which we required in order to construct a frequency distribution. In case I may mention one of them, of course, we had talked about the concept of a class width, which was a ratio between the range and the number of classes given as such. And we had mentioned that we're going to obtain the number of classes using the Sturges formula in this particular case. And we had said that we're going to confine ourselves to a particular number of classes, which we said are going to range between 5 and 20. And this is going to be a convenient way of trying to put data in a specific size that is, of course, manageable. Now, in this particular case, we had also talked about the concept of upper and lower class limit, which we said, of course, is going to be obtained from a specific number of classes, which we are going to obtain in this particular case. Now, in our last discussion, we had said that we are going to come up with 6 basic set of classes, and this was represented using these specific values for the lower and upper class limit of the first column given as such. So therefore, we said that we're going to obtain the class limits by trying to take the minimum value. Now, from our specific distribution, we had 6 as the minimum value and 39 as our largest value in that specific distribution. And therefore, this one formed a basis for us in trying to identify what we referred to as, of course, the range, which was, of course, a value of 33. Now, we had used this one in trying to obtain the number of classes, which we basically said were 6 by doing a roundup. So now, in this particular case, of course, we said that in obtaining the class width and, of course, the classes, we were able to arrange this specific set of data by having this first column. Now, then secondly, we talked about the concept of class boundaries, and they were said that we're going to obtain this specific class boundaries by having our lower class limit minus the specific units of measurement divided by 2. Now, in this case, we had said that the difference between this one and this one was 1 of these 2 consecutive, possible consecutive numbers of 11 and 12. And therefore, we had this one to evaluate our first, of course, the class boundary of the lower class limit given as 1/2. And this basically gave us 5.5. And in this case, for us to obtain the subsequent, of course, class boundaries, we added the value of the class width, which is 5.5 plus 6. And this gave us the next value for the lower class boundary of the boundary classes. Now, for the upper class boundary, we are going to obtain it by adding this specific value of 11 plus the value of u/2. And this, of course, gave us the value of 11.5. Now, for us to obtain the subsequent upper class boundaries, we added the value of 6, which gave us 17.5 for our first, of course, upper class, or our second upper class boundary for the subsequent class. Now, by adding the value of this class width, of course, we're going to obtain the subsequent values of this specific boundary. Then next, we performed an operation which, of course, entailed the concept of a class mark. And we had said that basically a class mark is going to be the average between the lower class boundary and the first upper class boundary of a particular class, which, of course, we said is going to be given in terms of the average between the 2, which is 8.5. Now, by finding the average between the upper and lower class boundary of another class, then therefore we're going to obtain this specific column. The frequency is the number of times in which these specific classes are going to be given. And of course, the cumulative frequency is the addition of all the frequencies of these specific lower classes in order to obtain the total frequency given as such. So we have 2 types of frequency: the cumulative frequency, less than type, and more than type given as such. and the relative frequency is the ratio between the frequency and the total frequency. So this is going to be given as 2 divided by 20, giving us the value of that one. So the particular column for relative frequency is going to be the ratio between the respective frequency of that particular class divided by the total frequency given as such, and this is going to give us this specific column. Now the relative cumulative frequency is going to be the cumulative frequency divided by the total frequency. Now in this case, I'm going to use this specific table in trying to, of course, do a summary of the various terms which we have come across. And this is going to assist us, of course, try to understand better this concept of frequency distribution table. Now, in this case, I mentioned about this specific set of grouped frequency distribution. Now, for a specific type of data, this is going to be distribution. Now, for a specific set of data which has been given in terms of classes or a frequency distribution where several numbers have been grouped in terms of classes, this is referred to as a group frequency distribution. And this is one of the examples of a group frequency distribution whereby we're going to have a number of classes given in terms of this specific frequency, and therefore this one constitutes a group frequency distribution. Now, I've talked about the concept of a class limit. Now, from our first column, we have given this specific concept of a class limit. This is going to be separating one class in a specific frequency distribution of this specific kind. And we're going to see that there are going to be perhaps some gaps between the upper class limit of the first class and the lower class limit of the subsequent class. And of course, we're going to see that in this specific set of data, then therefore this is going to constitute the class limit of a specific set of data. Now, for the concept of units of measurement, which are given in terms of units of measurement, this basically refers to the distance between the two possible consecutive, of course, numbers or measurements. And in this case, I've given an example of 12 minus 11, which is going to be 1. And this units of measurement can range between 1, 0.1, 0.01, etc. So in this case, this is going to go up in that specific order. And of course, that's going to constitute one of the concepts that we're going to come across in a frequency distribution. Now, I mentioned also the concept of a class boundary. And in our second column, in this specific, of course, illustration, I've given the column for the class boundary. And this is going to constitute a set of separation of one class in a grouped frequency from another. And of course, they're going to be different from the class limit in a sense that they are going to have one decimal, additional decimal place as compared to this raw data. And of course, apart from that, we're going to see that there's no difference between the lower class, the upper class boundary of the first class and the lower class boundary of the next one, and therefore there's no gap in between as compared to this specific first section of the class limit which I had mentioned. And then next, we're going to see that for us to obtain this particular class boundary, I performed a specific operation whereby we're going to have the lower class limit minus half the units of measurement given in terms of 6 minus g over 2. And this is going to give us 6 minus 1 over 2, basically, which is 5.5. And this is going to give us the lower class boundary of the first class. And in case we have to evaluate the, of course, the upper class boundary of the, or the upper class boundary of the first class, we're going to have this one as 11 plus u over 2, which is 11 plus 1 over 5 over 2, which is basically 11.5. And this is going to form the upper and the lower class boundary of the respective class in this specific order given as such. So therefore, this is going to constitute the lower class boundaries and the upper class boundaries given in this particular column. And then next, I mentioned the concept of a class width, which is going to be given as a class width given as such. Now, I said that basically we're going to obtain this class width by finding the difference between these specific limits for the upper and lower class limit, which is going to give us 6. Now, I used a specific formula which was W, which is equivalent to the ratio between. So for our raw data, we're going to use this specific formula, which is the ratio between the range and the number of classes in order for us to find a specific width by doing a roundup. So in this case, this is going to be consistent in a sense that if we find the difference between this one and this one, this is going to give us the class width. And of course, we can as well find it from the difference between the lower and the lower limits of any two consecutive of course, classes given as such. So this is going to be given as such. The lower limits are 6 and 12. So the difference between the two is going to be 6. The upper limits are 11 and 17. The difference between the two is going to be 6. So the upper and the lower class limits for the class boundaries are going to be 17 minus 11.5. The difference is still 6. And that's going to constitute this specific concept of a class width. Now, they talked about the concept of a class mark, which was basically the average between the lowest the upper class boundaries of these two specific classes are given as such. And the cumulative frequency is the total frequency which is going to be obtained, or the number of observations which is going to be obtained for the more than type or less than type of that particular frequency, which are of course elaborated on. Now in this case, the concept of relative frequency, as I said, is the ratio between this specific frequency of a class divided by the total number, and we're going to obtain those particular values. So in a summary form, this is going to constitute the grouped frequency table, which we're going to come across in our various discussions. Now in some cases, we're going to be required to construct a grouped frequency table, and I presume that from this specific discussion, then therefore in case we come across any term like a class width range, where of course the number of classes etc, it's going to be comprehensive for us. So that is it for now, guys. By God bless you. Catch us in our next video.